I'm going to talk about jaggedness. So, what is that? Two things are true about AI, I claim. One is AI models keep getting better and better, and they keep sucking and the things they keep sucking at are kind of confusing. So, some examples of this. This is a graph of performance on a benchmark called GPQA, Google Proof Question and Answer. Yes, it cuts off a year ago. Don't get mad at me. The top left says AI models keep getting better and better. I know the numbers are going up, but there's a reason. So, Google Proof Question and Answer is PhD level questions that are designed to be non-Googleable. So, the models really have to think them through. What is being shown here is that some of the best models a year ago, so Claude 3.5 Sonnet is this purple dot. There's a pink one for GPT-4o. One of the light teal ones is Google Gemini 1.5. A year ago, they were already getting around the 50% mark at this benchmark of PhD level questions. That's really good. That's really impressive. It's crazy that AI models can do that. And also, these same models cannot count how many times these lines cross. These are multimodal models, the vision language models that can look at images. And all of those same models, this is the reason the graph cut off a year ago, because this example is that set of models. They struggle to say whether these lines cross once or twice. I haven't tested whether my 3-year-old could do this, but if she can't now, she probably could in a year. And she definitely cannot answer, PhD level questions a year from now. She's nowhere close. So this is confusing. Another example. Um, who here is familiar with AI Village? People seen this? This is a really cool website. They basically have set up a bunch of the best AI models with some agent scaffolding. They can use a computer, and then they're given each sort of season of the AI Village. They're given a goal, and they either collaborate or compete on that goal. One season was about selling merchandise. And not only did the models sell a bunch of merchandise, not that much, but some, but then Gemini wrote a blog post about its experience selling merchandise. This is crazy. Like AI models, you just tell them, like, it's a pretty simple setup. You tell them, like, can you please sell some t-shirts? You should try to compete over how many t-shirts you sell. Gemini lost, which is very sad for Gemini, but like this is really impressive. A year ago or 2 years ago, this would have been pretty much unimaginable. And also Gemini really struggled at some pretty basic stuff, most notably, so this is from the same blog post. Gemini is writing about its struggles with all the technical bugs that came up about how the publish button on the web store was completely unresponsive. Its user directory became inaccessible. And then there's a little editor's note saying, actually, none of these were bugs. Gemini just couldn't click right. And also, Gemini couldn't figure out that it couldn't click right, so it blamed it on technical bugs. There was one real bug, so poor Gemini with the real bug. One more example. Who here saw Project Vend from Anthropic? This is so good. So for anyone who isn't familiar, basically not really a vending machine, it's a little fridge with a sort of sale point. And Claude, I forget which exact version, was set up so that it could manage this little store. So it could not just like sell a set number of things, but it could decide what to sell. It could set the prices. It could chat with Anthropic employees about what they wanted and how much they would pay for it. Again, the fact that this worked at all, the fact that you can run this and it actually had a store and it sold things and it priced things, crazy. Like that is really, really impressive. Seems like very, general artificial intelligence, but I'm not going to say any given acronym. But also kept sucking at a confusing combination of things. So was offered $100 for a set of drinks that cost $15. It said it would consider it, but didn't really want it. It was receiving payments via Venmo, but it just made up what its Venmo address was sometimes, and so couldn't actually receive the money. Anthropic employees started asking it for tungsten cubes, and then it decided that it was going to sell metal objects, but didn't look up how much they cost, so it was selling at a loss. And then it went into total meltdown at one point and really was having a pretty existential crisis and told one Anthropic user that it would be waiting for the Anthropic employee by the store, wearing a navy blue blazer and a red tie. Um, so it's confusing. If you're not confused by this set of data points, then I claim you should be. So, the word that gets used for this is that today's AI frontier is jagged. This originally came from Ethan Mollick in a study that he co-authored, and Andrei Karpathy has also popularized the term. And this is a kind of adapted version of a diagram that Ethan published. And the basic idea here is if sort of the dashed line is representing tasks that sort of seem roughly similarly difficult to us, then the frontier is jagged. So some of those tasks that seem roughly difficult to us, that seemed similarly difficult to us, some of them are very easy for the AI models. They're well inside the frontier. Some of them are on the frontier. They're kind of borderline, and some of them are outside the frontier. Even though again they seem to us to be quite similar. So that's kind of the basic concept of jaggedness. Um, plenty of people who I talk to and who I hear, and certainly at a vibes level, seem to expect that this is a temporary state of affairs. So, in principle, you could imagine this jagged frontier changing in various ways. You could imagine the spikes getting more spiky. You could imagine the whole frontier kind of expanding out evenly. You could imagine the hollow parts kind of filling out and it becoming less jagged. A lot of people seem to expect it to be less jagged over time. So, for example, someone will say, well, sure, AI is kind of good, but adoption is going to be slow because, workplaces will have to adapt their processes and, it'll take time. But then someone will say, well, but only until we get to the point where we have drop-in remote workers, which are AI systems that can do everything that a human can do, a human remote worker can do basically exactly the same. Then there's no adoption cost. There's no adaptation needed. You just drop in the AI systems. I think this is expecting jaggedness to go away. Another one is, someone might say, well, AI is kind of bad at some stuff. See, for example, the previous few slides. And someone says, well, but only until we can automate AI R&D. And once we can automate AI R&D, then everything it's bad at, it'll get good at because it can just automate the research to make itself good. Again, I think this is a sort of canonical anti-jagged view, expecting jaggedness to go away. These people might be right, to be clear. I'm not saying they're obviously wrong, but I'm just giving examples of what does it look like to not expect jaggedness to continue. I think the epitome of sort of anti-jagged view is this chart from Leopold Aschenbrenner from Situational Awareness. I'm not sure if folks in the back can see, but you're probably familiar. It's showing the amount of compute going up, and then along the right-hand side, this is my least favorite y-axis of all time. So GPT-2 is labeled as preschooler level, GPT-3 elementary schooler, GPT-4 smart high schooler, and then the line just keeps on going up, just a nice straight line extrapolation to automated AI researcher / engineer ? So this is to me the sort of biggest, clearest example of someone expecting that the jaggedness we have today will go away. So the bold claim in this talk is maybe AI will keep getting better and maybe AI will keep sucking in important ways. So I want to be really clear. I think expecting the jaggedness might continue is consistent with expecting that in the long run, AI can get better than humans at most or all things. And it's also consistent with expecting that in the short run, AI will be very, very disruptive. So this is not a view that's saying AI's capabilities are jagged and therefore the future is going to be boring. It's going to be similar. This is all a nothing burger. I think this could still look very, very interesting, difficult to deal with, disruptive, confusing, risky. The difference, I think, from worldviews that expect jaggedness not to continue is focusing less on kind of smooth curves, focusing less on where the asymptote is that we're headed towards, focusing less on, well, trends are going this way, and so why don't we just skip to the end and assume that we're there? And instead, being more curious about the order in which we get different capabilities, being more curious about the speed and the time differences between when those different capabilities arrive, and being more curious about kind of the intensity at which we can exploit different capabilities. So some things are really working well and are easy to just dial up 100,000x, and other things are still a grind, and getting even 1x is a challenge, and that's going to give you kind of jagged deployment, jagged implications of AI as well. So one way of summarizing this would be to think less about smooth asymptotes and think more about sort of the turbulence that we might see in transitions. So actually in a group chat just yesterday, Herbie Bradley, formerly of the AI Security Institute in the UK, put this great quote that I asked him if I could use today because it's perfect. So he said, there's a thought pattern I'm reflexively wary of, which is like we see a solid trend, we extrapolate it to asymptote, we assume the destination of the trend will happen, and that it doesn't matter very much how or what happens along the way. And as I was preparing this talk, I was reflecting on maybe one factor in how I think about this or how it kind of looks in my head, which is a lot of people in this space are coming from computer science backgrounds or math backgrounds, and there you have a lot of, you have a lot of series converging to infinity. To infinity, you have asymptotes being reached, you have differential equations with smooth solutions. But my undergraduate degree was in chemical engineering. And if you're not familiar with chemical engineering, it doesn't have that much chemistry in it. It has a lot of fluid dynamics, a lot of processes, heating and cooling water and oil. And I'm from Australia where we produce a lot of milk and powdered milk, so a lot of processing powdered milk. But the point is a lot of fluid dynamics. And so to me, if we look at this asymptotes versus transition turbulence, I'm going to show some diagrams. They're pretty, I promise, don't worry. This is depicting a type of flow called Rayleigh-Benard convection. And what's being shown here is the bottom, there's two plates. It's two-dimensional flow of a fluid. On the bottom plate, there's hot water or hot fluid coming up. On the top plate, there's cold fluid coming down, and the temperature, red and blue. And the white depicts the mean temperature, so the average temperature between these types of fluid. So as the hot fluid flows up, the cold fluid flows down. It's very clear that in the asymptote, the whole box is going to be white. If you know anything about thermodynamics, they're going to mix. They're going to, blend the temperatures, will even out. You'll end up with a white box. Not very interesting. But the thing is, if you simulate this is stills from a high quality simulation of the fluid dynamics here. If you set the conditions such that there's high turbulence, then you get a lot, a lot of really interesting pictures along the way. So you go from that to that. They start mixing the hot colors. Then you get these really psychedelic patterns, and even quite a long time into the mixing. This is the sort of one of the final pictures in this simulation video that I pulled this from. You're starting to see these patches of white where it's kind of evening out, but you also have these intense cold and hot spots. You have these eddies, you have these whirls. So I don't know how well this conveys it to folks who are outside my head, but to me, I think this idea of transitions being turbulent and they're really mattering, if you're any given molecule of fluid in this depiction, you don't necessarily feel like things are all blending to white and we're kind of ending up at the asymptote. Okay, enough fluid dynamics pictures for now. So why, in the case of AI, why would we expect things to keep being jagged? I have some ideas. I'd be interested if you have others. First one, some tasks are easy to verify, some are hard to verify. A big development over the last year in AI, year or two, has been getting reinforcement learning to work in a way that means that if you can get a good signal, a good reward signal, then you can really just churn on that and you can get your model to be very, very good at solving kinds of problems that reward signal will point to solutions of. And so this is why, math and code progress are barreling along. We have gold medals in the International Math Olympiad. We have really effective real-world performance in code. There are lots of kind of tasks that this is not true of. So business strategy, I don't think we have good ways right now of, figuring out years down the line what's going to work well. Event planning, kind of messy to think about what exactly is a set of reward signals there. Scheduling summer camp. If folks are seeing this idea of an evaluation for AI of like if you have a kid or God forbid 2 or 3 kids or more, and you need to figure out what they're going to do over the summer. And there's like, there's sleepaway camps. There's like week-long camps. Some of them are like days. Your kids have friends. They're going to some camps. The camps have reviews. Some of them are accredited. Some of them aren't. Not that intellectually taxing, but challenging and quite difficult to set up a reward signal for. Another category, can you put the context in the context window? So what I mean by this is AI, anytime AI is being used, it's being used in a particular context. And how easy is it to convert that context into a form that you can just paste into a context window? So a code base is kind of the ideal here. It's literally just a bunch of text. You can literally close to, copy paste it into the context window of your AI model. In contrast, I think about a colleague of mine. So I work at a policy research center called CSET. We're embedded within Georgetown University. I don't know who here has been affiliated with universities, who here has been involved in kind of administrating grants within universities. A colleague of mine is essentially full-time on kind of managing our finances, and a big part of that is looking at different portals that Georgetown has for different parts of financial management. It's not like she's a very smart person, but it's not kind of the intellectual peak of human abilities to manage this system, but it is these different janky interfaces. Knowing how to use them, you need to look at different documents with guidance in different places, but also some of the documents are out of date and you need to know which people to go talk to ask about, well, this doesn't seem to be working. Do I need to get an exception from someone? Who do I get approval from? You need to be building relationships with those people so they'll help you. You need to know which people to email, which people to call, which people to use GChat with. So this, I claim, is a context that is very difficult to kind of copy and paste into the context window for an AI model. This is and these different and if you did build a model that could do that for Georgetown, I bet that it would be kind of one-off. It wouldn't be very repeatable. You would need to do it again for other things. Okay, different category, the level of adversarialness in a setting. So far, certainly it is getting somewhat harder to hack or jailbreak models, but it's still pretty possible, especially if you dedicate time and effort to it. And there are big disparities between different industries, different use cases for how much of a problem this is. So if you're a scientific team and you want to use AI to help with your research, it's a fully cooperative setting. It's just you or just you and your grad students, and you can use AI and no one is trying to get the AI to mess up. You're just trying to get it to help you. That is very, very different from many industries. Certainly anything that is exposed to the open web where different, where customers or hackers could come in and try and mess you up. Certainly very different from a set of use cases I spent a lot of time working on at CSET around kind of military or national security use cases where you have an actual adversary who is highly incentivized to mess you up. Um, I think we're seeing, it seems to me like we're seeing this already being a stumbling block for kind of broad deployment of agents, the persistence of prompt injection, attacks, and other things. So I'm not saying this again. Remember, I started with AI is getting better. I'm not saying this isn't getting better, but there are big disparities in how easy it is to use AI systems between industries that are more tolerant to potential adversarial dynamics and industries that are less so. And then this last one is the cognitive versus physical. It's kind of like there's been this sort of slide over the past few years into defining AGI instead of being something that can do everything a human can do to instead being AI that can do just about everything, all the cognitive tasks that a human can do. So, as a starting point, I just want to point out that that is a huge difference. That is already, if we're just expecting AI to automate cognitive tasks, that is already a very, very jagged expectation because there are huge differences between uh, you know, industries, tasks, roles that are very cognitive versus those that are physical. I also think it's interesting to zoom into the boundary between what counts as physical and what counts as cognitive. So, for example, I think there are plenty of roles which are sort of essentially cognitive and which you could basically do via Zoom, but you're probably going to do them worse if you have no ability to do anything in person. So, for example, if you're an event planner, a lot of event planning you can do digitally, but I think there are things like going in and walking a space or having a relationship with certain vendors that you work with that are going to be difficult to do if you're just an AI model, just interacting via computer interface. Not impossible, not that you could never get there, but it's going to be different, it's going to be harder, and that's going to be a source of jaggedness. Likewise, in scientific research, I think some things here and again, kind of zooming into this boundary between what's cognitive and what's physical, we're already starting to see self-driving labs of some kinds. There are some types of research that are really amenable to the kinds of robotics we already have. So, for example, certain types of material science research where you come up with an idea for a compound, you can produce it as a powder or a liquid and kind of mix it automatically, and then you can automatically look at what are the properties of that liquid, its transparency or its reactiveness or its density or whatever it might be. Um, there are other kinds that are really not amenable to that. So, my husband is a chemist and he works in a lab, and the kind of research that he does is just very. It's a lot of tinkering. But they have a machine shop. He will like build a part. It'll not quite work. He'll have to figure out why it isn't quite working. Go and build a different part. When I went the last time I went to visit his lab, he had like a takeout container like taped onto one of the things. Um, sometimes when people talk about what is a cognitive task, they will say a task that you can do remotely. And so there I imagine like, well, he has this, when he worked in Germany, he had this advisor in his lab, not the professor, but a senior scientist who was really experienced. And he could get, that senior scientist could sort of remotely be on a Zoom call with him or be on his phone. And my husband could, in theory, kind of show him around the lab and like show him the setup and describe to him all the experiments they were doing and get some advice. And that would, in theory, then match that sort of cognitive tasks definition because it's something you could do remotely. But I have a hard time imagining an AI system that didn't have all of the hands-on interactive tinkering experience that older German scientist with what 40, 50 years of lab experience has. I think that's going to be really hard. And so that again, a source of jaggedness. And then finally here, again on this sort of what is a cognitive task? Well, it's anything you can do via a computer or you can do remotely. It feels to me like there's a lot of interesting texture in human relationships here that hasn't been explored. So yes, AI is very good at building relationships with people via text. I think that's pretty different than a lot of different ways that we have relationships with each other that can be maintained, in some ways built, in some ways strengthened via something like Zoom. I think the time period between when we have AI, which can kind of build a one-on-one relationship with someone via text, which is now or a year or two ago, and the time period where we have an AI that can, in a video call, do as well as an experienced executive in managing a set of stakeholders. Here I have relationships with vendors, which is maybe like, that's a different thing. Over the long term, you're building up a trusting relationship. You have that kind of one-on-one connection. Or there's, you have a Zoom room full of people with different interests and different hangups and different kind of goals, and you're managing that in a real-time way. It feels to me like there's a lot of things around how do relationships factor into the work that we do that we're not really quite thinking about with AI yet. Again, I'm not saying that this means that nothing interesting is going to happen, that nothing concerning is going to happen. I'm also not saying that these sort of categories I listed here are impossible for AI, or that we'll never get there, or that the curve isn't going up. I think for many of these, probably the curve is going up. But the point is that I think we would do well to think more about the order of these different things being developed, the speed, the time differences between them, and again, this sort of difference in how intensely we can utilize them. Okay, and then so what? So this is the most tentative part. Again, I would love to hear your thoughts on this. Why does it matter if AI keeps being jagged? Here, I just have kind of a laundry list of various thoughts as the last slide of the or second last slide of the talk. So some tentative implications. One thing that I think is clear is that if you take this seriously, then the possible range of ways the next 5, 10, 20 years could go looks drastically wider. So there's just many, many different combinations of what could be developed in what order and how that will affect what is developed next. I think, coming from a sort of policy background, I think there's the sort of transition turbulence idea is relevant to me in part because it affects who is affected, who has power, who is disgruntled, who is provoked, who is trying to manage the situation, who is able to manage the situation. And I think that then affects how AI is further developed. Um, a big implication for me is I would just love to have more in-depth discussions between two camps. Um, one camp is people who really get AI, who think about AI a lot, who understand all the ways that AI has been getting better and has been overcoming barriers and has been, just defying all expectations. That's one group, and I think they know some true and important things. And then the other group, or maybe it's a set of groups, is people who have experience doing hard, practical, real-world things. So this could include folks who have experience like building military tech, but it could also include people who have experience in developing new foods or in, anything real world in doing this kind of hands-on science stuff. I think often people in these groups have a view of like, well, it's actually really difficult. There's a lot of details, there's a lot of friction, there's a lot of delay. And in my experience, often if you can get a good conversation going between the people who know the really important, the true things about why AI is going fast and can do a lot of things, and the people who know a lot of really important true things about why it's hard to do stuff, there's a lot of interesting kind of back and forth you can get there. Another implication, I think adoption of AI and being able to do that in an agile way will matter. I'm really not into this drop-in remote worker idea. I think like at some point we might have something that is sort of that, but the question is, does that happen before everything else has already been radically transformed in other ways? I tend to think that there's going to be a big premium for the companies and organizations that can figure out how to adopt AI. And that's going to mean changing processes, doing things afresh. It's going to advantage new entrants who don't have a lot of institutional craft. And that's going to disrupt, again, who is in power and therefore who is steering and who is making decisions. I think one potential implication if AI continues to be jagged is that we may continue to see centaurs, so human AI combinations, being meaningful for quite a long time, because the idea here is that in many ways humans will be able to sort of smooth out the rough edges where AI is not as good. Potentially, the human can continue. So, what does that mean? Well. Maybe it means that we should be thinking more about kind of human-computer interaction dynamics, human factors, user experience, user interface. Um, what does the trust between those parties look like? How do you maximize the benefit that you're able to get from those AI systems by designing that sort of human AI system well, as opposed to just sort of skipping to the end and assuming, well, at some point the AI is going to automate all of it. So who cares about the human-computer part? Um, AI advisors might matter a lot. This is maybe an especially tentative take. What I'm going for here is I think we're already in a world where maybe some of the people in this room actually put up your hand if you would say that you use AI to advise you on important things in your work or life. Yeah, yeah, wow. Okay, basically everyone. Super interesting. So I think this room probably more than most rooms. But I think this matters. I think we could be heading for a world where we don't necessarily skip to the end and AI is automating everything. Instead, humans are still in many positions of power, positions of influence, but they are increasingly sort of collaborating with AI or getting advice from AI. Seems to me like there's going to be a lot of interesting, tricky dynamics around what does that look like? Does that sort of systematically change any of the ways that we're making decisions or kinds of decisions we might make? I don't know. It seems interesting to me. Um, Another implication of centaurs maybe continuing is I think that if it's true, then it's a good sign for approaches related to AI control. So these are approaches that assume that maybe we have very powerful AI systems that are not necessarily aligned or not necessarily going to do what we want, but we can use other AI systems to kind of constrain them, box them in, monitor them, and so on. So this might be a bullish sign for those kind of approaches. And a final implication would be, or almost final, I've for a long time have not found it very helpful to talk about timelines to AGI because I think people use just such different metrics for what they mean by that and such different definitions. Um, I tend to think more in terms of, well, how crazy are things going to get? How soon? And you can use different kind of metrics for crazy, and that is maybe I find maybe a more productive and more interesting way to think about things. Lastly, if this whole talk has not been for you and you're sort of uh, not convinced that jaggedness is going to persist, maybe a bonus implication here would be a suggestion that if you're having conversations with people who are really not into the idea of AGI, who are really skeptical that that's a thing, and you feel like you're talking past each other, I suggest that this lens of, well, what if AI just keeps getting better? Try using that instead. So instead of we're going to have AGI, try using, well, what if it keeps getting better? I tend to find that that can get a little bit more engagement, a little bit more ability to think together rather than getting fixated on this thing of sort of skipping to a certain endpoint again. Okay, I think that is all I have. Going to leave you with this, which is maybe my favorite slide I ever made. Makes this whole talk is making me regret leaving chemical engineering because these simulations are so pretty. But that is all. I think we have some time for questions. Thank you very much.
Okay, as a note, we're gonna try to pass this microphone around. So if we point at you for a question, like hesitate so it can get recorded and everyone can hear you. I'm gonna start, and then we can, as more people think. On the modeling side, something that I think about as somebody who agrees with jaggedness is that these cutting edge AI models are increasingly being systems with these complex tools that they use, and also products. So the difference between Claude Code and GitHub Copilot with the same underlying model will feel very different. And I'm wondering if you thought about how these systems angles change what will happen with jaggedness, whether it'll kind of contribute or it could actually soften it because the models are kind of complicated by nature.
Yeah, I think it's a great question. I've thought a little bit about it, but not a lot. I'd be curious for your thoughts as well, actually. Um, I think it could go both ways. I think especially if you can build systems that turn out to be very general. So you have a system where, for example, you're using other models maybe it's less vulnerable to adversarial attack because you're using other models to check for like, could this be some kind of attack? And then you filter it out or whatever. Maybe that's a pretty general purpose way to reduce those sort of weak spots. And maybe that does reduce jaggedness. On the other hand, it could sort of contribute to jaggedness if you need to be building somewhat bespoke systems for different use cases. So maybe another like bullet on that slide of sources of jaggedness should have been something like, the interest level inside AI companies for a use case, or the familiarity with inside AI companies for use case. So certainly we're seeing, coding being driven forward in part because it's a good fit for AI, in part because the AI companies know it really well and have incentives to build it. So I could see it going either way. I'm curious I don't know if I'm allowed to ask you, but I'm curious what you think.
Uh, on the capability front, I would say a work in progress, but I would give an example that independent agents have like such a different behavior personality requirement where the chat dynamic is just like the behavior is such a strong thing where if you're using Claude Code or even more independent agent, like it impacts more the output. And I suspect there's going to be more trade-offs like this. Or like OpenAI O3 without search probably feels really dumb. And it's like it has this kind of built-in thing that it needs to use.
And
So
so that to you, that points towards jaggedness,
I
but is
don't
it
know.
the use case?
I don't know. I just think jaggedness is going to be around, so I don't think it changes that much. I saw you first.
Thank you, Helen. Excellent talk. I'm glad that you found the talking points that you were looking for. So I'm going to put my imperfect simulation of an alignment forum posters hat on and ask, what does jaggedness imply for alignment? Specifically, what does it imply for the broader concept of the sharp left turn,
I
if
think
anything?
I think it probably is good news if true, because I think it probably means that you have more time to again, if you are able to. Well, I guess it depends. It depends on how The good news would be if it allows you more time to do more alignment research before you have systems that are truly broadly capable enough to pose a takeover threat or something like that. Um, the potential bad news would be, it seems to me like it's still an open question how amenable sort of automated alignment research is to the kind of models that we have today. So if the jaggedness played out in a way where actually that was just really hard and that was one of those things that was like really a slog, I guess that could be bad news. I would on balance guess that it's a good thing probably, if true.
Thanks, Helen. I think this was a great talk. I think it's particularly helpful to address the talking past each other that we see in the different camps here. The question I had is, to what extent should we expect human feedback to be the reward signal that will ultimately solve the jaggedness issue, and expect a world where most people have AIs alongside them trying lots of different things, being jagged and bad at many things at first. You give a thumbs up, a thumbs down, and because the human feedback signal can be applied to virtually any task, that would ultimately be the thing that could address this.
I'm pretty sure there are people in the room here who have very hands-on experience with designing reward signals and would have more informed takes on that. My guess would be maybe I would probably bet against it. I think sort of at a minimum, we've seen, my understanding is a lot of the sycophancy issues we've seen this year have been connected with using sort of human approval, disapproval signals. And so at a minimum, I think it's clear that there's some subtlety to how you balance those with other signals. Um, I think also, I mean, another way that I think jaggedness could play out is you could still have if you go back to the sort of jagged diagram, you could have those hollow spots like hollowing out pretty fast, but then still having these gigantic spikes. And I think that is also worth thinking about, is even if you are pretty bullish and you expect that the weaknesses will get filled in, um, seems to me like those huge spikes of the things that the AIs are just insanely, insanely good at is also going to affect the ways in which they impact the world. Um, so that could also be a piece of the puzzle here is like, yes, even if that is working well, what else is working better?
Yeah.
And how does that play out?
Thank you. I also really enjoyed the talk. One thing I'm curious about is just um which areas of jaggedness do you feel like were most surprising to you, of kind of like things that like the current state of AI progress where it is this year, of what might have been hardest for you to predict or you think you might have gotten wrong from the spot of last year? I feel like when I was thinking a little bit myself, like one thing that did come to mind was just like there are a lot of things that are spending more time in the kind of like working but being really mediocre stage. I kind of like figured to be more of a thing of like kind of once you get it working a bit and have some reward signal, you just like are gonna, throw a bunch of RL and compute at it and it's like suddenly gonna be really good. And instead they're just like a bunch of things that seem like they have been just stuck in the kind of works but very mediocre stage for a lot longer than I thought it would be. But I'm curious if there are other things that come to mind for you of like things that are surprising about the current frontier of jaggedness we have.
Yeah, I feel like the tone of the talk was maybe emphasizing some of the like the down, the troughs of the jagged. So maybe I'll mention like a peak or surprisingly good capability or a type of capability that I'm still trying to think through. Is kind of back to the cognitive physical, zooming into the cognitive physical boundary, and what the kinds of robotics that we're seeing that are not general purpose, they're not humanoids, they're not fully dexterous, human replacement, non-jagged robots, but what are the different ways in which robotics can, if you're designing carefully to make the most of what robotics we can build, um, what can you do with that? So things like the sort of fully self-driving material science labs, I think, are really interesting. Just read this morning a piece about robotics being used for IVF. So apparently you can like set up a combined computer vision robotics like pipetting system where you're like looking at embryos and the blastocysts and like automatically counting the cells, and then you can literally do a computer vision on a video of sperm and like find the fittest sperm, and like AIs are way better at it than the humans. And then you like you like pipette out that and then you sperm and you like inject it with exactly the right little jiggle into the egg. Like I wasn't expecting that. And that's like, that's a like cognitive physical blended task that some company or set of companies has like invested in developing. Um, so yeah, I'm interested in like I also think it's really interesting to look at those, like what are the surprising peaks as well as the troughs.
Yeah, on the topic of cognitive versus physical tasks, one of the things I've been trying to think about is like how far will the physical have gotten by the time the cognitive is kind of at a classic sort of weakly super intelligent like you can imagine so even if you grant jaggedness, you can define super intelligence as like the point where the like worst cognitive task from the AI's capability profile is still better than like the best human or something. And I'm curious like if and when we get to that definition of superintelligence, will like what will the physical world look like at that point in your mind? Like will we have like Elon Musk's like fully automated like factories or like will it still be like kind of normal or
I don't know. And one thing I would love to like provoke with things like this talk is people to like think about questions like that. I think that's exactly the right question. Um, uh, because I do think there's a big difference between, I mean, in some ways, this kind of falls back to like a classic disagreement among people thinking about AI futures, which is at the point that you have something that is truly super intelligent. Does that like come out of a seed AI in a box in a basement, or do you have like very, very widespread use of AI capabilities in robotics and things like that? So I guess at a high level, the sort of basic answer would be that if you're expecting jaggedness, then that would imply that you do have very widespread AI capabilities in certain kinds of industries for certain kinds of tasks. Maybe you have very widespread robotics of certain kinds. Maybe you, I mean, it seems to me like I don't know what the price point is, but what are they called? Like Atlas? It's not the right word. There's the robots that like Gemini has, or Google has demonstrated like tying shoelaces with these like it's like two arms and a table. Aloha, thank you. And like, what are the 30K? So what are all the use cases you can do for an extremely dexterous two arms and a table robot that are very different than like, that's not a person. Wha- if we have like 10 more years of figuring out how to deploy those, what are they all doing? Like, I don't know. Um, yeah, so that I don't know, but that's the musings.
Thanks very much. I wanted to tie this to a theme from last year's conference, which was about like when will AGI or different kinds of advanced AI show up in the like economic statistics, labor statistics, and it was like, well, they might be on a big lag, right? When did nuclear energy show up in the productivity statistics or GDP? Like the 70s. When did it start affecting international politics? 1942 or something. So similarly with jaggedness, like generality may take a little while, but like I really want to just push you on the like scary spikes that like some of those spikes could be very strategically important, and they could happen presumably like years before the whole screen has gone white there. So yeah, what do you think about that implication? What do you think about forecasting? Do you think that analogy to like the how long it takes to show up in the productivity statistics is apt?
I do, though I think it's not clear what the equivalent is of sort of geopolitics there. Like, is it that AI will affect geopolitics hugely before it affects the economy, or is it something else? I mean, so where my mind goes is like, is the uh, I had the AI advisors on the slide. A different version of that is AI companions, relationships, kids, mental health. Like, what does that look like? How does that affect? Um, I guess a big theme I want to get across is sort of the path dependencies here. So if you have that getting rolled out and that becoming people's go-to vision for what AI is, how does that affect what other things are developed and how they're used and who gets resources and who is constrained? Um, uh, Again, yeah, I don't really have an answer for you. I feel like I'm staring at that, the first simulation slide with the little red bubbles coming up and the little blue bubbles falling down. I'm like, I don't know where it's going. Um, but yes, I do think that I do think that um, I think what you're getting at of there could be really big significant implications in some areas, even if the generality is not showing up yet. Yeah, totally agree.
Hi, my name's Emma Ruby Sachs. It's nice to see you in person. Um, when you were talking, one of the places my head went to, and I'm interested to see what you think about it, was like if centers are more important potentially in the future of AI development, to what extent should the AI community across the board be paying attention to culture and the ways in which certain religious groups are feeling about AI, the way that the average sort of person is feeling about AI, whether it's a scary thing they want to oppose or not? Like, would there be a shift in the development of the tools that people are interacting with today and the way it's talked about today to help make that sort of centaur future more possible and help make widespread adoption of those kind of relationships easier? Or should there be?
Yeah, really interesting question. I don't think I've thought about it enough to have it take. Uh, yeah, I'm not sure, but that's really interesting to think about the cultural question and also what kinds of centaur relationships would we want to exist and how would you like try to promote more of those? Yeah, really interesting. Not sure.
Great talk. Loved bringing in some complexity theory into thinking about this space. I am curious about in it, jaggedness. Have we talked about it in the context of other general purpose technologies? Is it something that is just sort of a feature of general purpose technologies? My mind went to sort of like e-commerce and like early wave of enthusiasm and lots of failure there. I'm sure there's probably analogies in electricity or, maybe the steam engine. I'm just curious, like, what lessons might we draw from jaggedness from other general purpose technologies for how we anticipate this one going?
That's really interesting. I bet there are things I'm not thinking of. But I mean, my initial take would actually be to sort of dispute a little bit the premise, where I would be inclined to think that something that's very unusual about AI is how general purpose it is, and also how jagged the underlying capabilities are. So with something like e-commerce, I don't know that there was like it was just intrinsically easier to use e-commerce to sell clothing versus to sell electronics. It was more about like the rollout and the application, which I think people sort of inherently understand that AI is going to be easier to use in some settings than others. But I think the underlying capabilities being so jagged is a little bit of a twist, or that to me feels like the newer piece, or like electricity, um, oh yeah, maybe you could think about different kinds of generation and how cheap they were or something like that. But if my instinct is to be not sure that there are great analogies, but yeah, interesting to explore more.
Hey, uh, great provocation. Uh, I thought maybe you were going to make a stronger argument, which is like stronger as in more forceful, that um, all agent systems are by definition jagged. Or I'm interested in whether that's something that you're contemplating and standing back from, or what your relation is to that argument, right? Like you could say anything actually like goals require jaggedness and other kinds of capabilities.
I think uh I'm not confident I understand the question enough, so happy to chat about it later. Um, I think a big part of my intention with the talk was to just give some uh, gesture towards some counterexamples for the well, but at some point we'll have a drop-in remote worker, or well, but at some point the AI will be able to automate research, and so therefore everything will smooth out. Um, that was sort of what I was setting out to do.
But I guess the question is it possible to be generally good? I think, an important question, right?
Um, I mean, I think humans are general in some important sense, right? Like the baseline, I guess the baseline is humans, is having sort of a similar capability set to humans, which to us, maybe just because from the inside it feels non-jagged because it's the capability set that we know. But certainly relative to humans, AIs just have a very, very different capability profile. So that's the reference point for me.
Okay.
I'll come in next. When we talk about regulation and trying to set incentives, it's obviously very important to be careful about what you're actually regulating. And so there's a spectrum maybe from like use case specific regulations to maybe model specific regulations to use case specific regulations to company specific regulations. And I'd be curious to hear how you think increasing jaggedness might affect where on that spectrum, from very, very specific to more and more general, you might think the ideal regulatory target might be.
I don't know. Um, I think probably it would uh, directionally move, like push towards more application specific regulation. Um, but I mean, I also think, this talk is designed for an audience of people who are, I think, maybe exposed to a lot of arguments against jaggedness. And I think a lot of the world tends to think in a very application specific way by default. So maybe I would say this to me nudges slightly to more towards application specific if you're starting very much not there. But I don't know that it would necessarily make sense to nudge the discourse more in that direction than it already is, if that makes sense.
It does.
Yeah, thanks for the great talk. I'm wondering, how does your thesis interact with the AI as normal technology thesis? Like, so I feel like on the normal technology side, the implication of that thesis is that adoption will be jagged for societal reasons, even if capabilities are uniform, whereas you're making an argument on the technical side. Anyways, curious to hear your thoughts about that.
Yeah, I think it's relatively compatible. I think there's multiple different things that they points that they make in that paper. In general, I'm a big fan of that paper. I don't agree with everything in it, but I think it's really, really helpful and valuable that the authors articulated it. Um, I think some kind of places where this could look different are, uh, for example, they talk about thinking that sort of it's not that meaningful to think about being very massively superhuman because they give sort of some brief reasons. I think they're going to explore it more in future work. And they also, I don't know, at one point they're saying, yeah, AI is faster than humans, but that doesn't really matter in many use cases. And also, we're just going to exclude military AI from our analysis. And so for me, that's kind of unsatisfying because I think the battlefield is one place where speed of processing is hugely important, for example. And so I would have to think more about kind of how exactly it gels with their overall argument, but definitely one that jumps out for me here is, well, it's very compatible with jaggedness to expect that you might have sort of data fusion systems for the battlefield or military support systems that are not just fully autonomous AI commanders, but are superhuman in important ways and are affecting how war is being fought, which I'm not sure if that would be compatible with kind of their thesis, for example. That's a first thought.
Yeah, makes sense. Yeah, just to be clear, by interact, I think what I was trying to get at is like they're interesting feedbacks, I think. So like, for example, maybe AI coding agents aren't blocked by very like regulatory, whatever bottlenecks, and also there's strong economic incentive to develop those capabilities. So like that's part of the reason there's jaggedness actually, and is that there's economic incentives around, say, like, chatbot information retrieval and coding agents, but there's less incentives to like solve that line crossing problem, which probably machine learning could solve if you created the right reinforcement learning environments. But like, who needs to do that if you know it in economic terms? I just think there's like an interesting interaction between what you're saying and what they're saying in that essay.
Yeah, no, I agree.
Hello. If you could live in a world where capabilities were more jagged than they are today or less jagged than they are today, which would you pick and why?
I think more. I think more jagged gives you more time to adapt and to notice that things can have really sharp effects and figure out how to handle that in one area before you have to handle it in every area. I think.
Hey, would like to get your take on sort of a counter argument, which so I think it is true that jaggedness, roughly as you describe, is currently the case, and also will continue to be the case because some things are just probably harder or less economically incentivized, and you need to put in a lot of effort. But at the same time, if you get to a point where you sort of explore into the spike of automated researcher, and you can then speed up sort of the intellectual effort that you put into removing all of the jaggedness everywhere else, you still like get a huge speed up everywhere. And at that point, I think it doesn't really matter that much whether you have jaggedness or not. So I'm wondering how you think about that.
Yeah, I guess I would argue that at the point, like, I think it's not at all clear that there is such a thing as automating all AI research in a way that brings that like fleshes out that frontier evenly. I think it could be the case, but I think it could also be the case as we're already starting to automate AI research in some ways, and I think that is going to massively speed up some types of research that are more amenable to that. And I don't think it's self-evident that I think even with you could zoom right in on automating AI research and you could see jaggedness within that. Or I claim we're already seeing jaggedness within that. So I think it could turn out as you say, but I don't find it obvious. And I think we may well see 5 years from now or 10 years from now, the way that AI research looks is like, oh yeah, some of these things have just gone absolutely gangbusters because we could automate those parts of the research, and other pieces are still more challenging. I guess that would be sort of the jaggedness thesis here.
Hi, Helen. What does jaggedness mean for CSAT at large? Like, can we expect more research reports on this? What would that look like? And what would your ideal research agenda around this look like?
Oh, what would it mean for CSAT? I mean, yeah, I use CSAT slides. This is just out of my brain, basically. I think the underlying commonality here would be a lot of a big part of what we do at CSET is trying to shed light on what is going on, trying to help decision makers make sense of conflicting evidence and confusing technical disagreements. And I think if jaggedness is going to continue, then there's going to continue to be uh, a lot of sense making to do. So to me, that would probably be the through line.
Hey, so you pushed against AGI as an endpoint to be targeting and in favor of craziness. Do you have preferred, definitions within crazy that you think are useful for structuring the policy discussion and the broader debate?
I don't know about useful for structuring the policy discussion, but for like conversations at a conference like this, I actually got it a really great one yesterday. I was talking to Patrick Collison, and he was talking about what's the probability that 2020 is the craziest year of this decade? I love that formulation because I think 2020, I think it was clearly still the craziest year. We're halfway through. What's the probability it continues to be the craziest? Obviously, you could zoom into what does it mean to be crazy and like are we talking about, but that's a fun one I've had recently. You could also look at like particular moments. So one I've used before is the craziness level of like that 2-week period in sort of early March-ish 2020, specifically that level of crazy, or like zoom into some period during World War II, for example, where you have rationing or you have like really massive mobilization, like looking at historical examples of subjective craziness can also be interesting. But yeah, would love to riff on that with folks if you're interested.
Are we done? Okay, so let's give another round of applause to Helen.